World models. You've probably seen this buzzword popping up everywhere lately, right? From crazy new video generators to self-driving cars. But what does it really mean? Well, that's exactly what we're going to break down in this explainer.
I mean, let's be real, today's AI is pretty mind-blowing. It can write code, it can paint like a master, it can generate videos that look totally real. But for all that genius, there's this huge gaping hole between what AI can say and what it can actually do. It just doesn't have a basic gut-level understanding of the physical world we live in.
And this all comes back to a classic idea in AI called Moravec's paradox. It's this wild concept that says the stuff that's super hard for us humans, like advanced math or mastering the game of Go, is a piece of cake for AI. But the things a toddler can do without even thinking, like knowing that if you push a glass off the table, it's going to fall and smash, well, that's incredibly difficult for an AI. And this paradox, it's the key to everything. So this is the next great challenge for AI. Figuring out how to bridge that gap between just knowing words and actually understanding the world. It's not just some cool side project. It's the absolute next frontier for the entire field. Some of the smartest people in AI, like Yann LeCun and Fei-Fei Li, have put it perfectly. They say large language models are basically about saying things. They're like these incredibly well-read parrots. But a world model? That's all about seeing and doing things. It's the difference between reading a million books about how to swim and actually jumping in the pool and knowing how not to drown. So what's the solution? How do we teach the machine to swim? Well, that's where the world model comes in. It's this ambitious idea to give AI the one thing it's missing, its very own internal simulation of reality.
And to get what a world model is, all you have to do is think about how your own brain works. Right now, how do you know that a cup sitting on the very edge of a table is probably going to fall? You're not sitting there solving complex physics equations in your head, right? Nope. You're running a super fast, intuitive little simulation. That's your mental model of the world. And the whole goal here is to build an artificial version of that for a machine.
And this isn't some brand new idea that just popped out of nowhere. It's been cooking for decades. Way back in 1943, a guy named Kenneth Craik first suggested that humans use these little internal models to think. By the 90s, AI folks were already trying to build them into robots. But it was a huge paper in 2018 that really lit the fuse for the modern era, showing that these models could actually learn on their own, just from raw data. So, what does a world model actually do? Well, you can boil it down to three main jobs. First, it has to look around and just understand what it's seeing. That's representation. Second, it has to play out the future in its head. What happens if I do this? That's prediction. And third, it uses all those little simulations to figure out the smartest move. That's planning. All of that happens before it ever does a single thing in the real world.
And this table here, it just lays out the difference perfectly. An LLM, its whole goal in life is to predict the next word in a sentence. It learns from books and websites. But a world model, its goal is to predict the next state of the entire world. It learns from watching videos, from seeing things move and interact. One understands language. The other has to understand gravity. It's a whole different ballgame.
So with this being the clear next step, the race is on. And I mean a massive race between all the big tech companies and the top research labs. They're not just trying to build a slightly better chatbot anymore. They are literally trying to build entire simulated worlds inside their computers. Which, of course, brings us to the billion-dollar question, right? How in the world do you actually do that? Turns out there are a few very different and pretty competitive ideas on how to get it done. Okay, the two main approaches right now can be thought of as skin versus bones. On the one hand, you have video generation models like OpenAI's Sora. They basically paint the world's skin. They watch a zillion YouTube videos and learn to create these unbelievably realistic scenes, but their understanding of physics is kinda implied. On the other hand, you have the build the world's bones approach. This is about creating a true, structured 3D model of a place. It's less about looking pretty and more about creating an architectural blueprint that truly understands physics and space. But then there's a third, kind of radical idea pushed by AI legend Yann LeCun. He basically argues that trying to generate every single blade of grass and every reflection is a massive waste of energy. As he says, most of the pixels in a video are totally irrelevant for deciding what to do next. And his solution is something called JPA. Forget about generating pretty pictures. This approach tries to learn the abstract rules of the world. It doesn't care about the texture of a tree's bark, it just cares that the tree is a solid object you can't walk through. It's all about predicting the underlying structure of what's going to happen, not the visual details. It's way more efficient, but also a lot harder for us to look at and see if it's working right.
So, okay, we've got these different strategies battling it out. But what's the point? At the end of the day, what's the big payoff? Let's talk about the real-world stuff, where this tech is going to change, well, pretty much everything.
The impact here is going to be huge. For robotics, we're talking about machines that can finally work in a messy, unpredictable place like your kitchen, not just a perfect factory. For self-driving cars, it means a car that doesn't just see another car, but can anticipate what that other driver might do next. It'll completely change gaming and movies, letting developers grow worlds instead of building them by hand. And maybe most importantly, it's the key to creating safe, virtual playgrounds for powerful AI agents to learn and make mistakes in before we let them loose in the real world.
And listen, this isn't some far-off academic fantasy. The amount of money pouring into this space is absolutely staggering. Just as one example, a company called WorldSim, which is focused on that 3D building the bones approach, recently got a valuation of an incredible $5 billion. The belief that this is the future is very, very real. But, and you knew there was a but coming, with any technology this powerful, you have to look at both sides of the coin. The potential here is just mind-boggling, but it's matched by a whole new set of risks.
The promise is obvious. This feels like a massive step towards true artificial general intelligence. But the peril is just as serious. Think about it. When a language model hallucinates, it just says something silly. But when a world model hallucinates, it gets physics wrong. And that could lead to catastrophic failures in the real world. Not to mention the huge issues around a few giant companies controlling this tech, and the very real danger of blurring the line between what's real and what's fake.
We are right on the edge of moving from an era where AI just processes information about our world to a new era where it might actually begin to understand our world. This isn't just about making cooler videos or smarter robots. This is about giving machines something like intuition, which leaves us with one final and frankly enormous question to think about. When AI truly understands our world, how will it change it?